Logically, I think my presentation should have been first because it's very elementary compared to the completely power-packed engineering presentation by Mr. Surya Prakash. My presentation, honestly, gentlemen, is for the uninitiated. It is not for high-quality structural engineers. I'm here from a steel manufacturer's perspective rather than a structural engineering perspective, but I would like to give you some glimpses of our experiences in GCC especially, of how structural steel has been used and in building iconic structures. I'm very happy to be back in India, especially on a day when India has had a successful mission to Mars. It's truly a proud moment. While we are on the cutting edge of technology in areas such as space and other areas, we still have a lot of catch-up to do as a country in steel building, steel usage, and structural steel buildings. There are many reasons for this. I will go into some of the positives of how structural steel helps in a very elementary fashion, and then move on to some of the buildings we have seen in GCC and where we as Emirates Steel have contributed. And finally, I'll come on to the portion where I give a little bit of introduction on our company. These are known to everybody, but I'll just go through some of the benefits of using structural steel. Structural steel obviously gives you a lot of speed in construction. It is very practical and safe. We are now building over 800 meters very easily nowadays. The Burj Khalifa is a standing example. It's about 828 meters tall, if I'm not wrong. There is cost benefits. Because of the speed of erection, there is early occupancy with more rentable space. This should itself be a big driver in a country like India. There is a lot of aesthetic appeal because it gives a lot of flexibility in terms of how we design the facade of the building. Everybody knows steel has high strength to weight ratio, giving light buildings so lighter foundations which are less extensive and costly. There is ease of design with full integration between analysis, design, detailing, fabrication, erection, construction supervision, building cost and project management services, and intelligent management software. Last but not the least, with environmental concerns being on the top of the list, with leads and in our case STDAMA, I think steel is one of the most recyclable material. So it will be a very good point to keep in mind while designing with steel. This is a typical, mock-up made by one of our partners and customers, Evers and I, in terms of a simulation, in terms of the speed of construction with a steel frame and a RCC type construction. You can see on the 4th month, steel frame can move up to 23rd floor, and this is out of practical experience. This is not just simulation. Steel frame up to 27th floor, and RCC frame typically moves up to 7th floor with the same floor space area. And in 6 months, the steel frame can move up to 39th floor, and the RCC frame typically moves up to 16th floor. Sorry. And in 8 months, you can see the difference. It's up to the 54th floor and the 26th floor. These are not exact numbers, but these are based on practical experience. But ballpark, these numbers are correct. So obviously there is a great benefit in terms of the speed of construction with steel. This is known to everybody. It reduces the building height. Piping and ductwork can be routed through the beam openings, giving space and cost savings. I'll now come to some of the projects where Emirates Steel has been directly involved and just caption a little bit about the project and speak about the projects as we go along there. Just have to give me a minute. Yeah, this is the Midfield Terminal project, otherwise called the Abu Dhabi International Airport. It's the passenger terminal pier. As we are talking, this is under construction. You can see the sort of structure which has been built. This obviously cannot be built with concrete. This is a out-and-out steel structure. We have supplied close to 6,000 tons for this structure, and it is in the process of being built. We have supplied a lot of rebars also for it. We have supplied close to 150,000 tons of rebars for it for the first phase. This is a signature project for Abu Dhabi, one of the most prestigious investment. I think the total investment on this is close to $3 billion as of now. This can only be possible in terms of using steel. On our part, what we have done is we have delivered the 6,000 tons in cut-to-lengths, made-to-order sizes within a period of 3 months from the date of MTO delivery to us, which itself is a record. And this involved sections right from 203, 46 kg, up to a 634 kg, 356, 406. So there has been a huge range of sections, sizes, and lengths which we have supplied to this project. The next one is another signature project of Abu Dhabi, which is the Masdar headquarters. This incidentally houses the IRENA headquarters, which is the International Renewable Energy Authority. This is actually a 20-floor building, approximately a 20-floor building. You can see this is the simulated facade, and this is the actual building in progress. I am told by the fabricator that this whole structure was erected, including the decking plus everything, in a period of 6 months, followed by facade build-up and everything, and the building was ready in 14 months. This can never be done without steel construction. This obviously has some solar panels on the roof. It's a very energy efficient structure in terms of every aspect you can look at it. This is a beautiful building to see. It's worth watching this. The next one is a simple project, but this is more akin to what we might see in India in many places. This is called a Hub Zero project. It has a small shopping mall and everything else in it. This is again a typical steel frame plus a composite metal deck fast-track construction project. This is a G+2 structure. This was completed in 2 months. Again with structural steel from Emirates Steel, close to 2,000 tons is what we supplied onto this project. There are typical benefits. I don't have to tell the structural engineers, but for the uninitiated again, structural steel frame buildings have smaller columns giving more rentable floor area. Structural steel frame allows for longer cantilevers, giving architectural freedom to the architects. This was in one of the Kuwait towers. This is a picture of one of the Kuwait towers. As I said before, it gives greater freedom in facade appearances. You can have twisted structures like this. I don't have one of the pictures of the ADNIC towers at the Abu Dhabi National Exhibition Center, which is the most leaning tower in the world. That again is a completely structural steel-based structure. It's amazing building to come and watch. I think if some of you have the opportunity, you should have a look at it. Steel frames allow us to go higher. This is the top spire of the Burj Khalifa. It's 800 meters tall. Just for information for people who are not aware, from the 564th meter to the 828 meter, it's a full steel structure in the Burj Khalifa. There's about 10 floors from the 564th meter, which is built out of structural steel, which is used for offices and other purposes. There was 5,000 to 6,000 tons of steel used in this portion of the tower, and there is about 10,000 tons of steel used in the entire building for the main mechanical floors, as they call it, where you have the air conditioning and other this thing. So there's about 16,000 tons of steel in this building. It's obviously the tallest erection in the world, and if somebody builds something of this size, somebody wants to build something higher. The next one which is coming up is the Kingdom Tower in Jeddah in Saudi. It's the slated height for that building is 1020 meters. That's going to be a super tall tower. Again, there's going to be a lot of structural steel used in this. The next one is a beautiful example of structural steel usage. Though these sort of structures you will find only in the GCC where there is spare cash. You won't find it here. We will find more, fit for purpose kind of buildings here. But I'm seeing outside, I'm seeing a lot of very beautifully architectured buildings coming up in India also. It's very happy to see that. This is the Gate District Tower in Abu Dhabi. It is a flexible structure. The structure is flexible. It was built with speed, and safety of construction at super high-rise levels has been ensured by using structural steel. It's basically 3 buildings with a cap on top. The cap is entirely made of structural steel. The weight of this cap is close to 5,000 tons. And it's completely made of structural steel. This was not made with Emirates steel, even though it's written with Emirates steel. It predates us. Only the last portion of it, a little bit, we have supplied. These were lifted in modules of 650 tons each, again by using the jack which Mr. Surya Prakash mentioned. It's one-of-a-kind erection. The top structure of this could not have been done with RCC or concrete because you need to shutter up for such a height. I think it's close to 300 meters, this tower. And actually the cap on top is actually, you will not believe, it's a double duplex luxury set of apartments with swimming pools and other things on top. So it's an incredibly flexible structure. Also at these sort of heights, as Mr. Prakash was mentioning before, you have issues of wind and forces due to the wind to handle, and these are taken care of by structural steel sections like this. I have been associated with India for a long time. Obviously, I was born and brought up here. And I've been supplying steel from European mills, from Russian mills, from Ukrainian mills, and now from the mill in Emirates. I've always had a discussion, what will drive steel usage in India, especially structural steel usage. Some of the common answers which I've had and which I've tried to caption in this, probably some of you gentlemen could add to my understanding during the course of discussions later, are given in the next slide. The first point which I keep repeatedly hearing insofar as structural steel goes is regular availability of high quality steel and steel on the ground. Current production of roll beams is approximately 3.5 million tons in India, which for this kind of population is extremely low. GCC now has 2 million tons of high quality steel production, structural steel production. What is the population? Less than 80 million, less than 30, 40 million. We are a nation of 1.2 billion people with 3.5 million tons of structural steel rolling, out of which heavy structural rolling will not be more than 1.5 million tons. With that sort of structural steel production, it's very difficult to drive structural steel usage. The second important point, I think some of our Indian friends need to take it a little easy. We still use ISMB sections. We still use a lot of sections which are not entirely efficient for the purpose of design. Okay, I think we need to move to international designs. We need to move to international norms like British, European, American, or develop our own efficient standards. GIS, after all, is a Japanese standard. It is more efficient than, it's a mix of British and American, where you get lighter sectional weight. The second point which I consistently hear from many people is design expertise in steel. Our expertise as far as engineering is mainly centered around RCC and concrete. I'm talking about the general engineering background. I'm not talking about people like L&T. I'm talking about the general nature of engineering in this country. I have had experiences, the good experiences of visiting Hyundai, visiting so many other EPCs in Korea and other places. You see young boys, 23, 24-year-old boys designing complete structures in steel and for pipe racks, for major applications, and throwing it out every day. I think we need to develop that sort of expertise in this country in order to really design in steel. And it's up to the senior generation of structural steel engineers to inculcate, educate, and popularize that. I think we need to have more steel associations which go back to the institutes like the IITs and like the other places and tell them how to design in steel. It's not important that we study in IIT. We just learn what's in the book. I'm from an IIT, or I was a rookie. But what we need to understand is how to practically design in steel. The third most important point is proliferation of high-quality fabrication facilities. For example, UAE today has almost 10 world-class fabricators with a capacity each of 20 to 30,000 tons per year. Honestly, I cannot name 15 fabricators in India with this sort of capacity. For the size of the country, I would expect 20, 25 fabricators in this country. But that sort of capacity we don't find. Today, Emirates Steel, for one, is supplying steel to Korea for fabrication to be supplied to India. So I don't want to name the project. It's one of the largest projects in oil and gas in India. This obviously means that there is a shortage of fabrication capacity here. And this is the reprieve of the project manager there. He says, I cannot find fabrication capacity. I have no choice. He says, we're building a very large building. I'm only doing 10% of the building in steel simply because I can't find the fabrication capacity. I think you gentlemen would have guessed who is the company I'm talking about. And the last one, which will obviously, it's a demand-driven thing. Space and time-saving requirements will eventually drive structural steel consumption. In cities like Mumbai will benefit from space-saving constructions where real estate is at a premium. Previously, India used to pride itself on cheap labor and availability of labor. I'm sure now it's getting more and more expensive and more difficult to find labor. For you to find labor to do the work you actually want, there might be a lot of people, but for you to find people to deliver certain things, you will not find. So these sort of demand side drivers will eventually drive structural steel consumption. But we as engineers and suppliers of steel also need to do something to drive these consumptions. Okay. That's as much for structural steel usage. I am here sponsored by Emirates Steel. I should speak something on my company, otherwise I'll be in trouble. In very simple terms, Emirates Steel is a wholly owned subsidiary of the government of Abu Dhabi. We are a 3.5 million ton steel company. We produce about 2.5 million tons of rebars and wire rods, and about 1 million tons of heavy sections. We are not yet there in terms of the full capacity of the section mill. We are just a 2-year-old mill in terms of commercial rolling. Today we are at a pro rata rate of around 600,000 tons per annum. This plant came up with an investment of about $3 billion. If you notice below, this was the plant site in 2006, and if you notice in 2013, this is the shape of the plant. It's the largest integrated steel plant in UAE, or one of the largest in the GCC. We have our own iron making, we make our own steel, we produce our own semis, and we do the rolling. It's one-of-a-kind structural steel mill. It was supplied by Danieli. It's supposed to produce 1 million tons of sections. It's an integrated iron and steel making complex, state-of-the-art rolling mill. I think those of you who have an opportunity to come and see this mill should see this mill. It's really state-of-the-art. It can produce a wide range of products. We can produce the British sizes, the UBUC, the Euronorms, the American sizes, the ASTMWs, the PFC or the parallel front channels. In terms of size, this is a Rolls-Royce mill. We produce from 200 mm deep up to 1016, which is a meter-high beams, which is 8 to 40 inches in American parlance. And we produce from 46 kgs up to 634 kgs per meter. We do not use blooms, we use beam blanks, which we call as dog bones, for making the beams. The heaviest beam blank which we use is about 20 tons a piece. We call it the BB5. We produce all international grades of steel which is normally used. We produce from 275 up to 355 J2, which is an impact tested grade for offshore construction. We are currently carrying out trials on the S450, which is 450 megapascals yield. We hope to have this ready by October, then we can use it for some of the long span structures which is required in India. We can produce up to lengths of 24 meters. We also produce sheet piles for foundation and Z and U shapes. Sheet piles is another important product which we produce, which can be used for ports and other facilities. So eventually, what are we? We are a state-of-the-art mill producing about 1 million tons by the year end, with a complete range from 200 to 1016 beams across all strength categories. We have developed a track record with some of the most prestigious and technologically challenging high-rise oil and gas projects. Most importantly, we have a voyage time of just 3 to 5 days from India. We are able to service some of the large projects. We are supplying one of the large oil and gas projects, about 20 to 25,000 tons in 2 months' time. We are putting it on containers and sending it here. In fact, our freight rates are lower than the freight rates you will have from the east of India to west, and it's faster. That's it. Emirates Steel, we wish and we are sure will be a trusted partner. These are the beam blanks. This is one of my colleagues standing in front of it. This was shot just before we did the first rolling from the mill. Thank you, gentlemen. If you have any questions, we can discuss later. Thank you.